browser GUI. We've launched the server, and when we get the three messages like this, attach the server, fetching forest from the kernel, and the forest is empty, that's an indicator that server has been properly launched and is talking to the MeQ browser, and that essentially the server doesn't contain any leftover script or nodes from some previous run. So the first thing we have to do is we have to install an actual MeqTrees script to do something useful. We go up and we click on the TDL button. This will allow us to load a TDL script. We essentially get a pop-up window which sort of based on the standard Qt sort of file selector, and we want to scroll down until we find some Python code that we can load. Now here we are. The script I want to load is mgagwtree.py. That's actually the script containing TDL code to instantiate the little 6-node tree that we've described in earlier parts of these wiki pages. So let's go and open that particular script. Oops, I guess I made a mistake when I was actually writing the code. Actually, I didn't. I deliberately misaligned one line of Python code by offset by one character, and of course Python likes things nicely aligned, so when the browser tried to compile this piece of code, essentially what it's trying to do is execute this define forest function where we lay out all the nodes and their connections. It's come to a piece of Python it doesn't like, and what it does nicely for us is it pops up a little error message giving us an indication of what it doesn't like. And it's very convenient that you have this little arrow which then points to the line where you've got the erroneous piece of code. So we can easily correct that. Let's shift things one column left. We can now save our corrected piece of code. If we go up to the top of the editor, Oleg knows we've made a change, so this little save icon will have a highlighted background of yellow. We can click on that, and that's actually saved our updated code into the external mgagwtree.py script. We can now go ahead and compile that piece of code. Lo and behold, things work because it says now that it's ready to run a job. However, let's move this window out of the way and mention a few other things before we actually do that. First thing to note is that when we've compiled our piece of code, there's some messages and displays over here which tells us information about the nodes in the tree. We can look at things several ways. We can first of all expand this all nodes selector. And in the case of a small tree like this, this is probably a very convenient way to go. We see the names of the 6 nodes. They correspond to the names assigned in our script, and associated with each node is its type. On the other hand, if you have a large script with hundreds or thousands of nodes, and you're more interested in, say, studying a particular type of node, especially one common instance, for example, is you might want to look at the incoming data in one or two baselines and of an interferometer, and that usually baselines, incoming baseline data is defined in MeqSpigot nodes, so we could expand our class node list, and we could look for any MeqSpigots. Now, in our particular example, of course, we don't have any MeqSpigots, but say we want to see if we have a number of MeqConDec nodes we could study. We can expand our list, and indeed we see that in our case, of course, we just have one MeqConDec node whose name actually is Condec. Now, a common way to actually look at the tree when you actually try and run this tree and you have some errors in it is you might want to start searching down the tree from the root node. And the root node in our particular case is a solver. The solver has as its child the Condec node. The Condec node has as its child the MeqAdd node and the coefficient node, and the add node, of course, has our frequency and time nodes. So there we have our 1, 2, 3, 4, 5, 6 nodes, which are actually instantiated that you can see in the little diagram of this tree. Now, what can happen is when you try and execute the tree and you get messages about things going wrong, you can expand the tree in this particular way until you track down where the first node where an error is, the the errors will propagate up to nodes where things will turn red when things are wrong, and the nodes which have been are turned to red, you can then start investigating to see if there's something which is strange about it that you don't understand. And so investigating back from the root to the erroneous node in this particular way is a good thing to do. Okay, the other thing we want to do before we actually start a run is remember that we talked about the top part of our script. We had something called bookmarks. Bookmarks are essentially references we make before we actually run, telling the system which nodes we would actually like to get a visualization display for us. If we click on bookmarks, we can expand that, click on result, and then we're going to see that they're actually each node in our tree has a little panel subsection set apart, and the actual displays that the visualization displays are going to appear there when we run the tree. So we're now actually in a position to run the tree, and we can bring back a little command window, the TDL jobs and runtime options. In our particular case, the only job we can run is actually our very standard test forest node. So let's go and run test forest. There we go. What's happened is the script has run and it's filled the nodes with all sorts of data as a result of our as a result of the particular exercise. And what we'll do is in a further discussion and tutorial, we'll actually go and describe some of the sorts of things that we're seeing in these visualization nodes and what changes we can make to do further inquiries about what kind of data we have there.